Hi, welcome to your Algebra 2 Lesson 2.8. Today we're going to talk about graphing inequalities in two variables. So that's your goal for the day, to be able to graph inequalities that have x's and y's, two variables. A solution to a linear inequality is any ordered pair that creates a true statement when you plug in the x value for x and the y value for y. So the first thing we're going to do is check solutions of inequalities. So we're going to check whether the ordered pairs A, 3, 2, and B, -1, 4 are solutions of 4x plus 2y greater than 6. So if when we plug in the x and y value into 4x plus 2y greater than 6, if we get a true statement, then we do have a solution to the ordered pair. If we get a false statement, then we do not have a solution. So let's look. When we plug in 3, 2, we get 4 times 3 plus 2 times 2. That gives us 12 plus 4, that's 16, which is greater than 6. So that gives us a true statement. So 3, 2 is a solution. When we plug in -1, 4, we get 4 times -1 plus 2 times 4. So that's -4 plus 8, which is 4. The statement 4 greater than 6 is false. Okay, 4 is not greater than 6, so -1, 4 is not a solution. All right, when we graph a linear inequality, the first thing you do is you graph the boundary line, and you can do that by putting it in slope-intercept form, or you can find the x-intercept and y-intercept and play connect the dots. Doesn't matter. Use any of the methods that we've learned earlier in this chapter, but you're going to graph the boundary line for the inequality. You're going to use a dashed line for strictly greater than, strictly less than or strictly greater than, and a solid line for less than or equal to or greater than or equal to. Okay, so the dashed line is kind of like an open circle on a number line. It means that the boundary is strictly a boundary and not part of the solution. A solid line means that that boundary line is not just a boundary, it's actually part of the solution set. Step 2, you're going to test a point not on the boundary line to determine whether it is a solution of the inequality. If it is a solution, shade the half plane containing the point. If it is not a solution, shade the other half plane. If the point 0, 0 is not on the line, that is always a great point to check. If it is on the line, you need to check another point. Okay, just pick another point that's not on the line and you should be good to go. Okay. We are going to graph a linear inequality with one variable, but it is a linear inequality and we do want to put it on the xy coordinate plane. So we're going to graph y less than -1 in a coordinate plane. So the first thing we do is we graph our boundary line. So we're going to graph the boundary line y equals -1. We use a dashed line because the inequality symbol is strictly less than. Okay, there's no or equal to. It's kind of hard to see on there, but if you look closely, they've used a dashed line. If you're afraid I'm not going to be able to tell whether or not you've used a dashed line, just make sure your line extends out of the little piece of graph paper I have there for you and where I can see that the line is dashed. Okay, and next thing we need to do is test a point. The point 0, 0 is not on that line, so we can test it when you plug in 0 for y. 0 less than -1 is not a solution to the inequality, so we're going to shade the half plane that does not contain 0, 0. We're going to shade the other side. If we had gotten a true statement, we would shade the side with 0, 0, but because we got a false statement, we're going to shade the other side. Okay. This lesson's really short, so we're just going to do one video. Let's go on and do example 3. We are going to graph a linear inequality with two variables. We have 3x minus 2y less than -6 in a coordinate plane. Okay, so we're going to graph the line, and then we're going to test a point, and we're going to shade. So first thing we do is we look to see if our line should be dashed or if it should be solid. Because we have strictly less than, we're going to have a dashed line. If we had an or equal to part, you would have a solid line. You need to be aware of that on your problems to try on your own. One of the problems like this, you will have a less than or equal to, so on that one you'll need to make it a solid line. But on this one, because it's strictly less than, we are going to have a dashed line. So we want to graph this line, and you can go about it a couple of ways. You can find that the x intercept is going to be at -2, 0, and the y-intercept is going to be at 0, 3, and then play connect the dots. Or you can solve 3x minus 2y equals 6. You can move it, not really solve it, but transform it to be in slope-intercept form and graph from there. It doesn't matter, but go ahead, pick a method, take a second, and graph your line. We're going to use a dashed line because the inequality symbol is strictly less than. And then we're going to, once we have that line drawn, we're going to test the point 0, 0. Okay, so we plug in 0 for x and 0 for y. And so let's see, we get 0 minus 0, which is 0, is less than -6. It's not a solution. 0 is not less than -6. So we're going to shade the half plane that does not contain 0, 0. So we're going to shade on the other side. Again, if we got a true statement, we would shade on the side of 0, 0. On one of your examples, not examples, but problems to try on your own, you will get a true statement when you plug in 0, 0, and so you will shade on the side with 0, 0 in that case. Okay? If you need help remembering how to graph lines, look back at your notes from earlier in this chapter. At this point, I'm hoping that you're pretty good at graphing lines. Remember, we've got a test coming up, so you've got to be able to graph them. All right. Well, that's it. Try your practice problems, your problems to try on your own, and come to class with all of that prepared, and we will be ready to start the rounds. Y'all have a good day. I'll see you soon.